Hello, in these videos, we're going to look at how we can integrate tangent and secant integrals. This will be the last set of videos because if we can do tangent and secant, we can do cotangent, cosecant, and cotangent, cosecant, as they'll follow the same rules. So we'll look at the examples for tangent and secant in this video. So evaluating first the integral of tangent to the 5th times secant cubed. If we have an odd tangent, we can follow two different techniques. I'm going to show one of them, but I'm going to describe the other. If we have an odd tangent, we can turn this all into sine and cosine. And what this would end up looking like in sine and cosine is that tangent is sine over cosine. So we'd have sine to the 5th x over cosine to the 5th x. And secant is 1 over cosine. So secant cubed x is 1 over cosine cubed x dx. And now we have an odd power of sine. So we can use the strategies from the last video to integrate that. The other thing we can watch for in odd powers of sine is if we have both a tangent and a secant, we can do a strategy similar to the sine and cosine where we pull out both a tangent and a secant. So tangent to the 4th times secant squared times tangent x secant x dx. And then, just like before, the reason we're doing this is we're trying to set up a u substitution. We're pulling out what we want to become du, so we want ultimately du to equal tangent x secant x dx. And to get a du equals tangent x secant x, that means u is going to equal secant. So I want to get the rest of this written as secant. As before, tangent to the x, tangent to the 4x is tangent squared squared. And tangent squared is secant squared minus 1. Now, because we've made this substitution, we can say u equals secant x, du equals tangent secant. Here is du, and all the other secants will become u. So equals u squared minus 1 squared times u squared du. Expanding this all out, we get u to the 4th minus 2u squared minus 1 times u squared, or u to the 6th minus 2u to the 4th minus u squared du. We can integrate that to get 1/7 u to the 7th minus 2/5 u to the 5th minus u cubed over 3 plus c. And the last thing, we'll be plugging in our substitution, which our substitution was secant, giving our final answer to be 1/7 secant to the 7th minus 2/5 secant x to the 5th minus 1/3 secant x cubed. So there is our antiderivative of tangent to the 5th secant cubed x dx. Now, for an example of what if we don't have an odd tangent? Well, if we don't have an odd tangent, the next thing to look for is what if I have an even secant? If I have an even secant, we can do a similar trick. But instead of just pulling out one secant, or even one tangent, we want to pull out a secant squared. So factoring of these integrals is equal to everything else. And this still leaves the integral of secant x dx, but with a u sub trick, we know that the integral of secant x dx is equal to the natural log of the absolute value of secant x plus tangent x. We are just going to use that integral in this problem. So using that, we get that 2 of this tangent squared x secant x dx is equal to tangent x secant x minus the natural log of secant x plus tangent x plus c. Since we have 2 of these, we can divide by 2, or dividing by 2 is the same as multiplying by 1. And there, with some integration by parts tricks, we have found the integral of tangent squared secant